ಸೊ ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. ವೆರಿ ಗುಡ್ ಮಾರ್ನಿಂಗ್ to one and all present here. Today we have National Space Day celebration. So we have a distinguished scientist, Dr. Dilip Kumar Banerjee sir. So request please come on to the dais sir. And I request our CEO Dr. M. Ramesh sir to please come on to the stage. So please sir. So before starting this session, I request all of you please stand up for Nadagite. So thank you. Now I request please come in front. Lot of seats are there. Now I request our CEO Dr. M. Ramesh sir to welcome the guest and give the overview of this program.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. Good morning everybody. At the outset, I welcome you all to this one-day workshop on National Space Day program. We have with us very distinguished scientist, Dr. Deepankar Banerjee sir. He is the director, currently the director of Aryabhatta Research Institute of Observational Sciences, Nainital. In fact, India's space odyssey started with the launch of Aryabhatta on 19th April 1975, and the leader was our former chairman, Professor U.R. Rao, was also the former chairman of ISRO. Under his guidance, more than 20 satellites were launched successfully. Our second chairman was Dr. S.K. Shivakumar. I am sure all of you would have heard about Bialyalo antenna, deep space antenna. He was the architect of establishing it. And our previous chairman was Director General of ICR, Professor S. Ayyappan sir. And this, I must thank my friend Dr. Srinath for helping me in contacting Dr. Deepankar sir for this Space Day program. And I'm sure all of you know why National Space Day is being organized. It is to celebrate Space Day through the launch of Aditya. Aditya was launched very successfully. So our Honorable Prime Minister thought it right to have National Space Day because ISRO is our pride, and many satellites have been launched very successfully and are working successfully since 1975. And I am sure all of you know Chandrayaan was a successful launch on October 22nd, 2008. The average distance from Earth to Moon is 3.84 lakh kilometers. Subsequent to that, the Chandrayaan 2 was launched on 22nd July 2019. After that, Mangalyaan was successfully launched. The distance from us to Mars is about 33.9 million miles. After that, Aditya L1 spacecraft was successfully launched by PSLV C-57 on September 2nd, 2023. It is placed at 1.5 million kilometers from the Earth's orbit. And today we are celebrating Space Day through Aditya L1 journey. August 23rd is chosen to honor significant milestones of ISRO, to raise the awareness about the importance of space science and technology in India. Professor Deepankar would like to share his experience with the Aditya L1 mission. Aditya L1 is the first space-based Indian mission to study the sun. The spacecraft is placed at a hollow orbit of around 1.5 million kilometers on L1 Lagrangian point. A satellite placed in hollow orbit around L1 point has the major advantage of continuously viewing the sun without any occultation or eclipses. During his presentation, Dr. Deepankar will take a journey into the interplanetary space through Aditya L1 mission. Now, before starting his talk, let me give you a brief overview of Dr. Deepankar sir's achievements. Dr. Deepankar Banerjee is, as I told, is the director of Aryabhatta Research Institute of Observational Sciences, Nainital. The institute comes under the Department of Science and Technology, Government of India. He is an astrophysicist with a bachelor's degree in physics, and later he pursued his master's in theoretical physics from University of Kolkata. He has obtained his PhD from the very prestigious Indian Institute of Astrophysics and completed 2 postdoctoral tenures in reputed institutions in Europe. He is also a senior professor at Indian Institute of Astrophysics at present. Dr. Banerjee's area of interest is the sun and the solar atmosphere. His work involves theoretical and numerical modeling using data from ground and space-based instruments. His work has enriched our understanding of the sun and its impact on space weather. He is the co-chair of Science Working Group of the Aditya mission. Aditya is the first dedicated Indian mission to study the sun, launched by ISRO, as I told, on September 2nd, 2023. He is involved with NASA's Punch mission. He is a fellow of Indian Academy of Sciences, National Academy of Sciences, Royal Astronomical Society, and currently is the president of Astronomical Society of India. Dr. Banerjee has published more than 150 research papers in national and international journals of repute, with with over 3,900 citations in international journals. He is currently supervising 5 PhD students, while 15 of his students have already completed their PhD. If anyone is interested to pursue your PhD in astrophysics, sir is there with you. After his talk, you can contact sir. I'm sure, sir, some will be interested. Apart from his scientific career, Dr. Banerjee has interest in various other activities. He is a trained Hindustani vocal and part of a Bengali theatre group. Smaranic and regularly performs in plays, participating in national and international theatre festivals. And Dr. Banerjee's love for science and zest for life are infectious. So such a great personality we have with us on behalf of all of you and the people who have joined on YouTube, especially Mr. Vishnupant Kulkarni, who has joined on YouTube from Goa, and more than 100 students from Goa have joined this workshop. On behalf of all of you, I welcome Dr. Banerjee with a bouquet from my colleague, Mr. Srinivas. I also take this opportunity to welcome Dr. Basuraj, Dr. Giri, Dr. Srimati, and our KJYS Yalanka President Shringesh is also there with us, and faculty from IC Bio are also with us. Welcome to you all, and all the students from different science colleges and engineering colleges have gathered here. For all of you, welcome, and some have joined on YouTube and Cisco WebEx platform. For them also, hearty welcome. With this brief welcome, I request Dr. Deepankar sir to take over and deliver his talk. Over to you, sir.
Turn off these lights.
Yes.
Yeah.
You comfortable order? Make conflict.
Yeah, yeah. This will leave this from here. No. Should I get these chairs slightly out of the way? Yeah. So that it blocks the lower part of the. Good morning. So let me understand first how many students are with science background. Just raise your hand. Okay, that's pretty large. So, and with engineering background. Okay, so engineers are minority here, but I will try my best to also excite you about these missions, and particularly Aditya mission, where I am personally involved with. So thank you, Dr. Ramesh, for this invitation. It's a pleasure for me. I'm spent most part of my life, at least the academic life, in Bangalore, but currently I am in the Himalayas. I will show why I am in Himalayas. So it's always a pleasure to come back to Bangalore. And as you mentioned, my other interest and all that, I have a show in Rangashankara tomorrow at 7:30. So I do try to enjoy life through my, science and sports and other activities as well. So I would strongly encourage the youngsters to take whatever career you are, to do it with the zest and with the, enjoying it. So what is important at the end of the day is to enjoy the life, and that you can enjoy through your academic world, through your neighbors, the society. So it's all part of the learning as well. So here I am, and today we are celebrating, we're continuing celebration of this 23rd August, which has been announced by our Prime Minister some time back, because of commemorating the success of Chandrayaan-3 mission on August 23rd. So August 23rd was last year, was our great day of landing on the moon. This really paved a new phase of space technology demonstration from India, We have done this 50 years after the Americans did it, but still it is a big achievement because others have not been able to replicate that. Since we are a developing nation, even, you know, and that too, you know, we have landed in a location where others have not yet explored. Incidentally, yesterday, there is a paper from in Nature. Nature is the top rated international scientific journal. From the lander, lander had, and the rover had multiple instruments. I'm not going to talk about today much of the science from Chandrayaan because I'm not an expert in that. But I was so pleased to see from our own mission. So there is an instrument on the rover, and that you know, scientific results are published in Nature. Yesterday only it has come out in press. So I think we are getting into the really the top level of scientific, you know, endeavor also with our own instruments, with our own mission. This is also a big thing because this is all indigenously, you know, done within the country. And Atmanirbhar Bharat, what we are trying to achieve to showcase our achievements. So I think there is a lot of governmental support for, you know, commemorating this this kind of big achievements. So the land happened 1 year, you know, before, and we had the first Nature paper yesterday from instruments. As a scientist, I think these are the, you know, best achievements. Of course, technological achievements is important. That's why we need the engineers to take us to, you know, destinations where we can't even think of, or where when I was young as you, we never could think that we will, you know, do this kind of ventures. But for us as a scientist, it is also equally, you know, or even more exciting when we are able to publish in the top-rated, you know, international journals. There, the credibility comes as a scientist as well. So here you see the Bikram, and this is what the program deployment I was talking about, the first Nature paper which has come yesterday of life as well. So that's the purpose of the Space Science Day, very briefly. I will now talk about where I'm coming from. We have two campuses. This is in Uttarakhand in the Himalayas, one old campus in Nainital, but the new campus is at Devasthal. This is my office in Nainital, and sometimes you see beautiful, you know, things in the sky as well, because you know, it rains and then suddenly the weather really clears up so well. This is the largest telescope in this part of the globe. From Asia, this is the largest optical telescope. This is situated in Devasthal. It's a 3.6 meter. I will not talk about too much because that's all, you know, branch of astronomy where I. So this is the campus at Nainital, and this is the campus at Devasthal, which is 50 kilometers east of Nainital. This area is called Mukteshwar, and it hosts now all the new modern big telescopes are actually coming up there. The 4-meter liquid mirror telescope also was inaugurated last year. It's a nice campus in Nainital. This is the student hostel. This is an old 1-meter telescope, few smaller telescopes. This is our auditorium here. These are the, you know, office space and small labs and so on. And that's the plains in Haldwani. So we are about, you know, 7,000 feet from the ground. This is the real big telescope site at Devasthal, which I was referring to. And you are most welcome to visit us anytime. There is a small telescope called 1.3 meter Devasthal optical telescope, which is our PhD students' toy, because only our PhD students work with that telescope. It's on their mercy. And of course, when you observe throughout the night, in the morning you can have a cup of tea and you can see the Himalayas in the background. You see any Himalayan peaks, you can identify them. This is a new telescope which is inaugurated last year only, 2023. This is the largest liquid mirror telescope in the world for astronomical observation. This is of course an international project with Belgians and Canadians as very active collaborators. And this is giving us this kind of pictures, which you know, you can look at galaxies, you can look at extragalactic source, supernovae, you can look at dead satellites. So this is again a very, very big problem we have today, that we are launching too many satellites. What happens after the satellite life is gone? They becomes a kachra in the sky. So literally there are millions of kachra in the sky now, and this is a big problem for us. because those kacharas they call it space debris. They get disintegrated. They got into small little pieces, and that piece can again interact with a new satellite which you are launching, and will destroy the components of these satellites. And we are now talking about launching constellation of satellites. Apparently, down the years, few years down the line, you won't need a mobile tower anymore. All your mobile phones will directly talk to the satellite. There will be that many, and broadband. Of course, these satellites will not be that high. They will actually fly much lower heights, which is also a problem, because then the kacharas are much closer to Earth as well. So these are very new avenue which earlier people never have even thought. So now, if you launch a satellite, people also have now discussed what will happen after its life is over. Will you be able to take it back to the Earth, or will you be able to park it somewhere where it's like in the modern world. If you buy electronic gadget, when you buy an electronic gadget, actually you pay for its recycling cost also. You cannot throw away the electronic gadget. If your TV is gone bad, you cannot throw it outside. You have to call somebody, some agency will come and pick it up. For that, actually you have paid when you have bought the TV. That cost is also included. Here we just throw away, our batteries gone bad, we just throwing it. Of course, in Bangalore there is some little bit of better awareness. At our campus, we have strict penalty for not segregating the garbage. So this is a garbage in this. So this is actually a dead satellite. These trails are actually dead satellites trail. We are detecting that through astronomical. So what is happening now? It is the defense organization, it is the space organization. They are all collaborating with astronomers to do this. So how multidisciplinary it has become. I mean, Air Force engineers are actually coming and visiting us for getting the training. Of course, they are also interested to understand which are the spy satellites. For defense purpose also, space is really getting very. So the space science is just not the science alone. It is a direct impact of our society, our day-to-day life. I'm sure if your WhatsApp doesn't work for half a day, you get all excited. I mean, very disappointed. So it is the space which is responsible for all our communication, all our television, network, and so on. GPS. You take a Google map, driving, suddenly GPS connection goes, you are lost. You don't know where to go, left or right. So our day-to-day life is so much dependent on these kind of services. Space is going to be really dictate the supremacy of the country as well, whether it is in defense, whether it is in communication, whether it is in technological demonstration as well. Supremacy. Why did the Americans land in the moon 50 years back? It was a Cold War going between the Russia and Americans to prove supremacy. So I think this awareness of the space, and to understand the space, you need multidisciplinary branch. So I'm just showcasing few examples so that you feel excited. My sole interest of these kind of sessions is to make some excitement on you. Incidentally, you can ask me questions during the talk also. I don't mind at all. You just raise your hand and ask me questions. Don't hesitate. You don't have to wait for the end. And if I have, say, 40 slides, if I cover 20 slides also, I have no problem, because it's important to have interaction. Of course, I will be hanging around after my talk, and you can personally come and talk to me as well. But please feel free to raise your hand and ask me question now, because I will be talking about many different things and you may not be able to remember. You can take a note, but so that option is also there. Just raise your hand and a question. So let me stop by and ask anybody having any questions of what I have stated so far. I've not got into the subject yet, not into Aditya yet, but nonetheless, I'm happy to answer any query you have. Very quick run? No? Everything is clear? Okay. So let me then get into sun. That's the star I work on, and I think we are here because of the presence of this star in the sky. If this star would not have been there in an appropriate distance away from us, we would not have been here. Our life is because of the presence of the sun and the radiation what it gives. But again, if the sun becomes a little angry tomorrow or changes its radiation pattern and all that, our life will cease to exist. Of course, Earth has also its own magnetic field, and that actually protects us the particles and the material which is coming from the sun sometimes because of certain explosions happening in the solar atmosphere. I will talk about it. So what is I'm showing here is sun, like all stars, is a very dynamic star, always active, always changing. The more we learn about it, the more we learn about all stars. So this is, since this is a very in our proximity, we are able to now observe the sun with such greater detail. You see here, there are regions in the on the solar atmosphere. These are called active region, where it looks like things are much brighter as compared to other. And now we know that all these regions are because of the presence of very strong magnetic field. So very strong magnetic field confines a lot of plasma material. And these plasma material, these are called coronal loops. So corona is the outer atmosphere of the sun. I will talk about it a little more, not the virus corona. Incidentally, the coronavirus was named after looking at eclipse images of the sun. Because when total solar eclipse happens, the solar disk is completely blocked by moon. And you see this, helmet kind of structures and these kind of streamers, we call it rays. And that image has been there collected for centuries. So when the biologists saw the virus picture in the microscope, they said, oh, this looks familiar. We have seen this picture somewhere. So it's a SARS virus, of course. But that particular variety, they named coronavirus by looking at solar coronal image only. So there is a link. Sun is not responsible for the virus. but the name came from actually the total solar eclipse image. So not many people actually is aware of that. But often I give a warning that please don't blame the sun for this. Sun has nothing to do with its, its origin. But the name has some link. So here, what you see is that a lot of plasma material is confined within these closed structures. They are called coronal loops. But sometimes these structures become unstable, and the material which is confined within that, they can be thrown into interplanetary space. So these are called solar storms. And then, these material will travel it through the interplanetary space and can reach us. Of course, Earth has its own magnetic field, so mostly it protects us, but the satellites which are in the space is beyond magnetosphere, they're not protected. They're getting bombarded by this. So I will show the area of new research which has come up on that. So here again there is a movie. These are all taken from space satellites. So far it was always NASA satellites or European Space Agency satellites which we were using. Hopefully you will see more images from Aditya in our future presentations as well. So here you see that this huge portion of material which was confined, some of it goes out, some goes back to the sun, and then brightens up this and it hits up the atmosphere and so on. So these events are called solar flares, and it leads to ejection, and they are called coronal mass ejection. Mass is ejected in the corona and they travel. So to follow these coronal mass ejections, we need to really look at the sun remotely with multiple instruments, and what I'm showing you here, these instruments are called coronagraph. Basically, we artificially create a total solar eclipse kind of situation. We block the solar disk because solar disk is million times brighter than the atmosphere. So we don't see atmosphere of the sun on normal conditions at all. Only during totality. I don't know how many of you have seen any total solar eclipse. Have you seen total solar eclipse? Yes, Sir is here with a lot of good experience, and I'm sure Sir will say, agree with me how phenomenal it is. You get awed. What is this happening? So none of you had the opportunity to see the total solar eclipse? Yeah, unfortunately in the south part of India it has not passed much. Mostly it is in the north of India. I have been fortunate enough to chase the solar eclipse in different parts of the world, and I've seen about 9 total solar eclipses from aircraft, from Air Force flight to all the way to China to South America and so on. last in April there was a total solar eclipse in US. I was there too. We did some experiments as well. So here that instrument what I was referring to is called the coronagraph. That is following these ejecta as it comes from the sun, and you see that huge material. I'm sure you won't be happy to walk around here, right? And now why this field is also becoming important is because the real rich people like Mr. X, they are proposing space tourism. They want to take people to the space just for fun. And if that happens and they are traveling into the interplanetary space and such a big storm happens, they cannot protect the individuals. So the biological effect, a lot of energetic particles will be bombarded, cosmic rays. So you have to understand when such a storm is likely to happen and avoid journey during that time. It's very similar to that, a fisherman doesn't go to the sea for fishing when such a big storm is, likely to happen. So this a new field is called space weather. The weather in the space, how, because this is also very crucial, I will talk about it for the satellite launch and all that. All the satellite trajectories get heavily affected if there is a storm. The movie to showcase that if such a storm happens, you are seeing this from the low corona. That means, you have to identify where the source is of that particular storm, and then these are two coronagraphs which is following this storm. These are called heliospheric imager, and then finally it reaches out. So we need to really track all the way from when the storm happens to reaching the Earth. So if there are satellites here, then we can say what time the storm is going to arrive. As you see the weather prediction, we need to do the space weather prediction to really, so a lot of these operations affects our day-to-day life in a big way. So this field is called space weather, and it affects the astronauts' safety, as I indicated. Of course, in International Space Station also, there are people out there. If there is a solar storm, they have to take extra precautions for that. If we are talking about our Gaganyaan mission, we really have to worry about the dosage of these highly energetic particles when a real astronaut from India is going to travel. So we have to have a very precise, predictions, and then, find out the mitigation. What happens is when these these particles interact with the ionosphere, so the ionosphere is also very much important for our all communications, because the electromagnetic wave goes there and then it comes back, it reflects, and that's how our radio communication happens. So if ionosphere itself gets changed, the densities get changed, our communication system also gets affected. So we get loss of communications and so on because of the solar storms. It can directly impact with our lot of power stations. What happens is the electrical grid, these are what you understand in your laboratory storms when it impacts atmosphere. So in Canada in the winter they had a power cut of 12 hours in heavy winter. So all the metro got operations got locked. And it's not like India, we are habituated with having our UPS and other backup generators and so on. But in the Western world, they don't normally get power cuts. So there was a huge solar storm which impacted a lot of electrical grid system, and apparently they just paid insurance, kind of penalties of $100 billion, $100 billion, because everybody, charge the insurance companies and all that. So now the insurance companies are actually asking solar physicists, can you predict this? Can we take some precautions? Maybe we will draw power from some other country during that period. We'll take gas from somewhere else, not from our own generators. So it appears that space weather is now a service. So obviously space weather prediction is important for now defense, for all the satellite communication system, all the satellite companies who are launching satellites. In fact, again, Mr. X, whom I am talking about, the Twitter owner, he also owns this company called SpaceX. They launched in 2022 40 satellites. There was a solar storm before, and he was warned a little bit as his attitude, he never bothered about it. It says it's a small storm, it will not happen anything. So they launched 40 satellites and 39 of them got lost. Simply what happened was they were supposed to go to 300, 400 kilometer height, but since there was a storm, 1.5 days before, it changed the ionosphere and it changed the density profile. So when you are actually launching a satellite, it is going through, some density medium, right? If the density changes, your drag force changes. So simply the drag equation, if you would have solved, so that's why the mathematicians or physicists come into picture. And in fact, there is a company in Bangalore, Digantara. They had hired my master's student now. I don't know with what fat salary, but he's just doing that. So he's just doing space weather modeling for launch. So SpaceX lost its 39 satellites just because they did not calculate the modified density profile in the atmosphere, which changed the drag force. So all these satellites reached up to 200 kilometers and came back and got lost. I mean, basically got absorbed. So they got all dead. So he lost the entire mission of the cluster. So now Mr. X is also very careful about space weather predictions. So the launches has to be always timed in a way when such a solar storm is unlikely to happen in space. So there are many such effects when you are taking a very long haul flight from say Delhi to US. Nowadays it doesn't go through Europe. To shorten the path, it goes through the polar region. It goes to Greenland and so on. So that means it is going very close to Earth's polar region. So Earth's polar region means you are heavily getting exposed to all these energetic particles which are coming from the sun. And for pregnant women, actually it is quickly no. I'm not sure.
Of the spacecraft preparation facility. This is the Aditya L1 spacecraft being prepared and ensconced into a protective container where the environment is controlled and the temperature is controlled, the cleanliness is controlled. At the vehicle assembly building, again, there is a clean room provision to safely integrate it to the rocket, and then the heat shield halves are closed. Now the vehicle is fully ready to be moved to the launch pad, which is about 900 meters away.
So Aditya mission is very much for
This is PSL. The mission intends to place the spacecraft in 235 by 19,500 kilometers orbit with an inclination of 19.2 degrees. The total mission duration will
अब हम प्रमोशन से 22 मिनट की दूरी पर हैं। आदित्य L1 सूर्य का अध्ययन
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift off normal.
P1 tracking.
PT tracking.
magnificent liftoff of PSLV C-57 with Aditya L1 on board.
Plus 15 seconds.
PSLV C-57 का सफल उत्थापन और इसके साथ
20 seconds.
प्रथम भारतीय सौर अंतरिक्ष यान निकल चुका है सूर्य के तेज से विज्ञान को प्रकाश करने।
Air lead strap on ignited.
इसके साथ ही एक और कदम है अंतर्ग्रहीय सफर में भारत की उपस्थिति सिद्ध करने का। आप देख रहे हैं PSLV C-57 प्रथम चरण पूरी तरह सामान्य।
The rocket flying forth, following nominal trajectory and developing.
का जहां
longer movie, so I will not go through the full thing. So essentially, there was a different phases of this, particular launch, because this is the first time we have traveled that far. No, we have heard that it's 15 lakh kilometer ki duri par. So that's a big achievement. So for that, the different stages, are there, separations and all that. I will not go into so much details. Just very briefly, Lagrange one point is actually a location between the Earth and the Sun. It's only 1% of the distance which we traveled between Sun and Earth distance. So Sun and Earth distance is called 1 astronomical unit, and we have only traveled 1% of that. but it is far away from Earth and Earth's magnetic field. So directly you are looking all the time towards the sun. And as you heard from Dr. Ramesh's initial statement, that this gives us a unique opportunity to look at the sun 24/7, 365 days. Anything coming from sun, before it reaches Earth, it has to pass through the Lagrange 1 point. So we have a direct measurement of these properties of these particles or these huge cloud which is coming before it reaches Earth. We'll have a early warning possibility from there. Of course, there are other Lagrange points. L2 is where the JWST for other astronomical big research, L2 is very, very suitable, not for solar observation. L5 and L4 are again very two different, very huge vantage point to look at the sun as well. I have to tell this a little bit of background, why we had this L1 mission, because it is all due to one gentleman where we are standing here in his name. It's Professor U.R. Rao. In fact, Aditya was supposed to be a small satellite mission with one scientific payload. But then after that we were building, so it was approved in 2006, 2009, we were building, started working it in IIA with that instrument. But then around 2012, Mangalan success was there with us. So Professor U.R. Rao called some of us, I was fortunate to be one of them, for that time I was still younger, and said that would you like to travel a little far? Then we said, far means where, we are supposed to go 500 kilometers, is it, a little more than that? He said, Lagrange 1. We couldn't even believe what he's saying, because I was involved with the SOHO mission, which was the European Space Agency's, first Lagrange 1 mission. It is still active. SOHO is still alive. It was launched in '95. So he was aware of that. So he said, we have to play a major role in the development and all that. And he, proposed this to the Space Commission. Of course, if Professor Rao suggests something, everybody has to accept. And then announcement of opportunity was given. Many different institutions across the country, they actually submitted proposals for new instruments. And that's how the Lagrange 1 mission was actually born. Without Professor U.R. Rao, I think this is impossible. And it doesn't happen anywhere else in the world actually, because it is some visionaries who can think much beyond what our capabilities are and take that as a challenge. Because you have to take such challenges in life, then only you can achieve. If you are always thinking small, then you cannot actually reach that destination. So I think a lot of credit goes to sir. And I think some of us have been fortunate to, and all the review committees and all that, he was the person who used to review our, progress, the science, what we can do with it and all that. So amazing personality. So that was the trajectory of the Aditya mission. This is also another interesting thing from have done it. So China has a very active space program. They have done lots of lunar missions as well, but this is one mission which we have, I think, overtaken them as well in terms of technology demonstration and science. So that's how the Lagrange insertion was, and we are making this kind of halo orbit around. So we are not staying anywhere, though it's called L1 mission. L1 is actually a three-dimensional point. It's a fictitious point where certain forces balance each other. Basically, a satellite has a gravity pull between, the Earth and the satellite, and the satellite also has a force, attractive force between the sun and the satellite, right? But if you have to make an orbit, you need also a centripetal force. So the centripetal force, what is required, is provided by this balance between the two forces. So it's a much complicated three-dimensional thing. Don't think it in terms of a one-dimensional plane like that. It doesn't really make a one planar orbit also. It makes a sort of Lissajous figure, if you have, some of you have worked on it. in this. So it's a fairly complicated, orbit, maneuvers and all that required, which needs lots of simulation, and that's the credit I think the ISRO, scientists working behind should be given, because it's only European Space Agency and NASA has been able to do that. So we are the third to, able to do this. That needs a lot of, research element as well. Again, I will have a short video for the different payloads.
The Aditya L1 mission carries a suite of 7 scientific payloads to carry out systematic study of the Sun. The Visible Emission Line Coronagraph, VELC, studies the solar corona and dynamics of coronal mass ejections. The Solar Ultraviolet Imaging Telescope, SUIT payload, images the solar disk in near ultraviolet and also measures the solar irradiance variations. The Aditya Solar Wind Particle Experiment, Aspects and Plasma Analyzer Package for Aditya, PAPA payloads study the solar wind and energetic ions as well as their energy distribution. The Solar Low Energy X-ray Spectrometer, SOLEXUS, and the High Energy L1 Orbiting X-ray Spectrometer, Helios, study the X-ray flares from Sun over a wide energy range. The magnetometer payload is intended to measure the interplanetary magnetic field at the L1 point. The science payloads of Aditya L1 are indigenously developed by different laboratories in the country. VELC is developed at the Indian Institute of Astrophysics, Bengaluru, Suit Instrument at Inter-University Center for Astronomy and Astrophysics, Pune. Aspects Instrument at Physical Research Laboratory, Ahmedabad. PAPA payload at Space Physics Laboratory, Vikram Sarabhai Space Center, Thiruvananthapuram. SOLEXUS and Helios payloads at UR Rao Satellite Center, Bengaluru, and the magnetometer payload at the Laboratory for Electro-Optic Systems, URSC.
So you can imagine that such a big mission, involves so many people across the country, so many laboratories, so many individuals are involved. So it's a pity that I'm giving the talk, but it's really several hundreds of people walked with several days and nights for this mission. So as I was indicating, we are at L1. We have a combination of remote sensing instruments and in situ instruments. Remote sensing instruments mean you are sitting in one location and remotely you are observing it. So these are the 4 remote sensing. These 2 are X-rays, this is optical and infrared, and this is the near UV. This is also a multi-wavelength observatory class mission, and these are the particle measurement instruments, PAPA and Aspects, and the magnetometer measures the magnetic field of the interplanetary space, and also if there is a magnetic cloud which comes from the Sun, it will give us an indication how strong the field is, what is its direction. That actually gives us a ability to predict when such a magnetic cloud hits our Earth's magnetosphere, what kind of changes it will happen in Earth's magnetosphere. So it is our first multi-payload observatory class mission. It is multi-wavelength, covering different atmospheric layers of the source region, and combination of these are the remote sensing instruments, the big fat elephant which is sitting on the top deck, built at IAA. This is actually, we have a laboratory in the Hosakote campus, which is also was responsible for the Astrosat, payload development and all that. I'm not talking so far about our other astronomy mission from ISRO. SUIT is this near UV imager which was built in Pune, and these are the other smaller payloads built in different parts of India as well. And if you know the electromagnetic wave, this is the spectrum from the shortest to the longest wavelength. So our coronagraph has covering this wavelength, SUIT, near UV, X-rays, shorter wavelengths, and then you have the particle detectors and so on. I will show you glimpses of first results from some of the instruments. So SUIT is a filter-based imaging instrument. We have 11 filters to cover different layers of the stuff. This was the first day when the door was opened. You know, we always get lots of tension. It's just a command, you know, and the door opens. Suppose it doesn't open, then it's all gone, huh? Or telescope door doesn't open because you don't know where to go there and you know, to change some nuts and bolts. So this is also another very, very big challenge for a space mission, that there is no question of any failure. You have no option. You see, the command has to be responded, as simple as that. In a ground-based experiment, you go to the lab, you know, you have multiple attempts. So this also is a very, very big challenge for any space science experiment, that how confident and how sure you have to be. So these are the images which is taken from the SUIT instrument. As I was saying, that these are called the sunspots, the strong magnetic field region, surrounding regions are called plage, and the so-called other regions are called quiet region, but nothing is quiet in the sun, believe me. And then now we have demonstrated how these dynamics in the quiet region are responsible for a lot of you know, our atmospheric changes and all that. So we are getting you know, good images from this telescope. This is the X-ray spectrometers, which we have two X-ray spectrometers, which is looking at the integrated flux, and this is the flares. So these spikes corresponds to big flares, and comparison with the NASA satellite called GOES is showing, which also gives us a lot of confidence that our results are very much, you know, in line with international quality. This is another you know, spectrometer which is called Helios, and for comparison these are the two NASA satellite results. In fact, I would say that the green line, if you look at our you know, results, are even showing finer details because we have better temporal resolution. That means, you know, we can take many you know, data more frequently. If they are taking in, say, 1 second, we are taking in milliseconds. So that allows you to see the variability of the you know, of the flare and all that with better precision and all that. So here you could see very clearly we are having, you know, this is all little early results, I would say, because you know, we just completed one orbit, and a lot of calibrations, lot of, you know, still corrections to be done. There were actually several flares during month of May, because sun is very active now. Sun is actually peak of its magnetic activity. So lots of flares are happening. Other thing which I want to show, that ISRO captures the signatures of recent solar eruptive events from Earth, Sun Earth L1 point, and the Moon. This is actually Chandrayaan 2. A lot of you have heard about Chandrayaan 2's little bit of, I would say, failure in terms of the landing. But Chandrayaan 2's a big success is that orbiter. Chandrayaan 2 has an orbiter which is still orbiting actually and giving us regular science data. And it has been even orbiting the Moon in so many times that we are really getting lots of new information about the Moon. And apart from that, it is also looking at the Sun. So the solar fluxes and all that, we have published n number of research papers of high impact from that you know, Chandrayaan 2. In fact, the Nature paper which I was referring to yesterday, it is you know, one you know, PRL team, led by PRL team, Physical Research Laboratory in Ahmedabad. One boy, you know, Mithun, his PhD thesis I just you know, corrected last week. He worked on Chandrayaan 2. He worked on you know, the instruments on Aditya as well. So these results, and from Chandrayaan 3, that lander also. So it's a Mithun's work. He's the second author in that Nature paper. It's just for your, you know, youngsters thing. He was a IIST master student, joined the PhD program of Physical Research Laboratory of 5-6 years back, and have contributed significantly to these 3 different instruments on Chandrayaan 2, on Chandrayaan 3, and also on Aditya. And now he has a Nature paper. Of course, he has a secure job also. I'm sure a lot of ISRO people will be able to ready to hire him as well. So he's a product of IIST, which is the institute in Trivandrum as well, of ISRO. So what I was again indicating that now for any astronomy observation or say solar observation, we need to look at the sun from multiple vantage points as well. not from one location, like, you know, you just look from Earth. So this is an observation from Udaipur Solar Observatory. This is a ground-based telescope in Udaipur. This also belongs to ISRO. This is at an active region. I was talking about, you know, the active regions are places where this, you know, huge concentration of magnetic field and all that. So that's the source. We are at L1. So after a few days, these big storm will travel and will hit at L1. We are also, you know, we have an EXPO-SAT mission. This is a mission which is again led by RRI, Raman Research Institute in Bangalore, not too far from this place. So this is a mission to look at pulsars. So these are objects, again, you know, with long distance away for other astronomical polarization properties. EXPO-SAT has also got the impact of this solar storm. So we could record certain things from EXPO-SAT, we could record certain things from Chandrayaan-2 orbiter, and of course at L1, and from the ground. So how coordinated these observations has to be. And you can think about then how this multidisciplinarity comes into the picture. Different institution, different skill sets, different wavelength coverage. So it is really, the space science is opening up a new style of operations actually. And coordinations, you know, timing, interaction, collaboration. So I think it's much more exciting as compared to beforehand, you know, scientists used to go quietly, sit in an office, do some calculations. Of course, that was their own style of functioning. But today, modern day demands much, much more than that. And I enjoy that, you know, kind of work. So this is the active region which I was talking about, which has given many, many flares. Not one flare, but many flares. And this is from Aditya. So all these flares have been detected by Aditya. There have been so many X-class flares. So X-class flares are the strongest flare coming from the sun. And you know, certain phases you will find one X-class flare in 1 year. And it happened to be that in last, you know, in the month of May, we had so many X-class flares. And this is all observed by, you know, our Aditya, you know, one of the X-ray payloads, SOLEX. This is the other payload called Helios, which is looking at higher energy, you know, fluxes. SOLEX looks at lower energy fluxes. Helios looks at higher energy fluxes, and it also has recorded all this. So this is in the 6 to 60 keV, and SOLEX, if I run back, it is, you know, it's not written here, it's 1 to 20 keV range with an overlap with the Helios as well. So these will be also published in very good scientific journals. This is a magnetometer. As I said, when such a flare happens, it also gives rise to big ejecta. And this ejecta means, you know, it's like a huge magnetic cloud. You know, you have seen those, you know, ejecta traveling into interplanetary space. When it reaches L1, our magnetometer has an extended boom, and it will record these changes. So you see that, you know, the, you know, how much the, you know, magnetic field changes is happening. And the duration of these magnetic field changes, all these also allows us to do the space weather prediction as well. The timing of it, duration of this, the strength of this. So all these are very, very vital information, and now we have ability with our own satellite to do this kind of space weather science as well. So last few slides, I want to also point out that for heliophysics system observatories from international scenario, you know, there are many, many satellites. Many satellites. Some are in the planned phase, some are acting and all that. As I indicated, you know, as far as India is concerned, for science explorations, we have started much late. Because, you know, post-independence, we were focusing mostly on Earth observation, imaging, defense. So science is a bit of luxury, you can say. But if you want to be called as a developed world, you have to do science as well. Otherwise, you have to always borrow technology from outside, and they will not give you the latest technology. They will give you old technology to work with. We always get, you know, old cars models, not the latest model which is launched by Europeans. So although we have started late, but thanks to, again, visionaries like Professor Rao, we have started with a bang, because we have already got to L1. You know, we were expected to get, you know, small satellite programs, you know, low Earth orbit and all that. But in one go, we have overtaken many. So it's a really golden era of space science, to be honest, you know, and it all belongs to you. So if you want to really take, you know, India forward, get involved more into the space science. So that's the Space Science Day celebration is I think very apt. And if we can motivate, you know, some of you in whatever way, that will be our success story and our satisfaction as well. I would like to point out that ISRO is also now very much interested to enlarge the user community. At the end of the day, we launch this satellite, we have this data. Who all are using this data? Is it just, you know, few old, you know, white beard scientists like us? We need youngsters. We need, you know, the next generation to look at the data. Because we have certain ideas, but that may not be enough, right? You people will have new ideas. You have to be much more exploratory type and all that. So for that, you know, we have a Aditya L1 support cell, which I am the PI of that, which is now at Nainital. What we do is we regularly conduct workshops, training workshops and all that. So the next one is actually in IIT Indore. So we have already conducted 8 workshops at different parts of India. There have been some Aditya, you know, workshops in Bangalore also. I think one St. Joseph has organized one, you know, last year. So I will be involved with this, you know, this kind of training workshops and so on. Please, look at our website. You'll find much more details. You can also, you know, contact me as well. So we provide, you know, this kind of training programs for master students, so that, you know, and we will give you, you know, some data to play around with, and also, you know, train you how to process the data, because all scientific, you know, payloads provide a data which is, you know, which is not really, it's just not a simple image, you know, you have to do some processing, you know, I mean, data analysis is a little bit of an involved process. Once you get trained, you can easily do it yourself as well. So that is what our aim is. Of course, we also conduct a lot of, you know, training schools on observational astronomy and all that at Nainital. So this was the last year's photo, which is here in this slide. But this was my lifetime experience. Of course, you know, Nigar Saji, the project director of, she's also from Bangalore. I don't know whether you met her, so must have seen a lot of advertisements and all that. And, you know, my colleagues out there. We were all there inside during the launch. I won't forget about it throughout my life. And thank you for your attention. And please do come and visit us. We will be happy to show you the Himalayas as well. Thank you. Yeah. Yeah, please feel free to ask questions. If you don't ask a question, I will be disappointed. I will think that I have not been able to convey anything. So please feel free. Yeah? Somebody has to start. Yeah. How long this Aditya L1 mission is expected? Okay. So the question is how long the Aditya L1 mission is expected. So normally ISRO says a term called nominal life. Nominal life means that life is guaranteed. So the nominal life is 5 years for Aditya, but we were already told the launch and the trajectory maneuvers were already so good that we have saved a lot of fuel. It all depends on 2 things. One is the fuel, and the other thing is also the life of the individual instruments, which ISRO cannot guarantee always, because the instruments are built by very different people and all that. As far as Aditya is concerned, I would say I expect 10 years easily. Since you asked the question, the SOHO was launched in '95, it is still alive. So that way, the Lagrange is again a very special location where these, you know, forces, as I said, this 3-dimensional force balance is so much that you may not need much fuel at all. So it's actually orbiting once in a while, once in maybe 2 months, you need to use a little fuel to correct, because there will be some deviation. At the end of the day, it's a 3-dimensional body. Other bodies are not really taken into. You see, Sun is 99% of the mass of the solar system. So we don't have to worry about smaller bodies. other planets and so on. But in a three-dimensional n-body simulation, if you take other bodies, you will have a little bit of perturbation. I'm just giving you an example. That will have a small little deviation. So to make that correction, they will need to use the fuel once in a while. So again, coming back to like I said, 10 years, I would say we should be there, and maybe much longer. Yeah. No. The solar power is only used for the energy for the instruments. So the instruments need to have power for the cameras, many electronic gadgets to send the signal and then to operate the electronics. You need power. So the power is generated by the solar panels. The fuel is required for the trajectory changes. So that's the the fuel which is used, different kind of fuel combinations which is used for that. Yeah. So it will all depend on how much the technology changes and all that. One thing is that we will need even powerful engine and launch vehicle also. So in our whatever understanding launch vehicle, so ISRO is also parallelly doing lot of research in alternative fuel, alternative next generation engines, rocket launching and all that. In fact, India did not have all the capabilities of cryogenic engines. We were a lot dependent on Russia and so on. Yeah. But now we are completely self-reliant. So that's why, see, you will notice that GSLV launch was sort of stalled for a few years. And once we have our own Mark III engines, we can go anywhere. But how far we can go and all that will depend on, also it depends on the mass of the payloads and all that. Heavier you take the payloads and all that, of course, a lot of energy goes into that as well. So we are talking about going to L5. In fact, again, Professor U.R. Rao, one Aditya L1 was pretty advanced stage about 6 years back, 7 years, 7 years. He called again some of us and said, would you like to go to L5? That's much farther away and all that. But then he said that whatever payloads you are building, you just make a duplicate and then send it. But then being a scientist, I said that if I go to L5, I need a different instrument, not the same instrument, because L1 is looking at sun-earth line, L5 is looking from the side, so I need some other instruments to complement and all that. So then he said that, oh, that will take much time. You are the same guys, I cannot give you too many things. So you deliver L1 and then we'll go to L5. He did say, so that proposal is still there. Unfortunately, if you would have, that proposal would have been accepted, we would have been first in the world. Now L5 mission is approved by European Space Agency, it's called Vigil. So it is now scheduled to go in 2032 to 35 times here, which has been just approved last year. So if Professor Rao would have been here, I'm sure we would have been the first. So that kind of cloud he had, and if he says others will accept it. Very powerful. Very More questions from the students? Yes. You can take the microphone for other benefit. Yeah.
Hello. Yeah, so my question is, you had mentioned about the 5 Lagrange points from L1 to L5, and just now you have mentioned like Professor had proposal of the L5. So my question is, like, among the 5, is it proven that the L5 is the very next optimum point after L1? Like India is at Aditya L1 right now. So what probably is India targeting after L1? Is it L5 or any other among 2, 3 and 4? Yeah. Is there any other points which can give us more information about the sun apart from L1?
Yeah, it's a very good question. So essentially, if you want to look at the sun, so just let me try to get into that slide, which will probably help you to understand a little better. Yeah. So, so here is the sun, and this is, let me stop this movie so that it becomes easier to, yeah, let me pause it. So here is L1, we are directly looking at the sun. L2 is not good for sun, But L2 is very good for astronomy, because it also protects from the solar, sort of effects and so on. In fact, the JWST, the biggest optical telescope now, is at L2 now. For solar, L5 is a very good vantage point, because we are able to see the sun. Sun also rotates about its own axis. So when we are looking at the sun, 3-4 days or maybe almost a week back, what is coming towards the sun earth line, we'll be able to see it before. So L5 is fantastic for space weather, because from L1 we are only seeing this part of the sun, and at the edge we are not able to see. When we are at L5, we are able to actually tell what is coming. So we will have a huge opportunity to do space weather prediction. L4 is good for certain other reconstruction and all that, but it is coming later. So it's not good for space weather. But what is now important is, see, any object in the space, if you take, if I take a image, I get a plane of the sky, right? I don't get the 3D picture. But if I take a picture from there, if I take a picture from there, I can do a 3D reconstruction. So I have a much better knowledge about that object, and I think about that object if it is coming towards us. So the reconstruction is much better if you have multiple vantage points. So that way L4 will be helpful to understand the 3D picture of the sun. And L3 is also not bad, but the problem is, not bad, it is very good actually for knowing perfectly back of the sun. But if you are in L3, you can't get the data out, because sun is blocking. So if you have, people are even talking about having an L5 mission, having an L3. L3 will talk to L4, L4 will transmit the data to you. So you get even 360-degree view of the sun. So all these are in the thought process. But now if Vigil is already approved, whether we will really benefit from going to L5, we are debating. We are discussing on that, because the payloads what we proposed to build and take it to L5 is already going to be there in Vigil. So having said that, always it happens, like people have gone to L1 before also. SOHO had 13 instruments, but we have not replicated that 13 instrument. We have built new type of instruments which complements new understanding. So that is how the science goes. So it is not always that somebody is already there, so you don't go there. But that impact, doing it first, won't be there. But as far as science is concerned, we'll always find something new with the new instrument kind of thing. So we are doing that. But then again, there is a European Space Agency mission which is going out of ecliptic. So all this is actually in the ecliptic plane. We missed the one also very crucial information about the polar region of the sun. So unless we go out of ecliptic, we will not get a polar region. So why Chandrayaan is being also very much credited, because it has gone into the polar region. So if maybe we should think about a polar mission. So we are scientists, we already had several meetings on this regard. What will be the most optimum next mission to plan for? Yeah, good. Yeah. Yeah. Yeah, yeah. It's again a very, very good question. So what is sir asking is, at L1, because it is coming from the sun, so of course, it is somewhat, directly looking at the sun. But the point is, the temperature is not a very, very big problem. Okay, so he will get a prize? Yes. Okay, very good. So I will just come back to you. Very good, well done, thank you. So we are still away from the sun. So the thermal effect is not going to be too much of a problem. The Parker Solar Probe, one movie I showed, that is going actually much closer. So they can't even look towards the sun. Yeah, so see, we have lots of protections and all that. So it depends on what material you are talking about. You see, if so typically for all experimental things, laboratory electronics and other, we try to maintain it in the room temperature, because otherwise, the things will melt. But again, if you want to have a shield, so that particular material, what kind of composite material can withstand the temperature and all that, it could be several hundred degrees centigrade and all that. So material which is used for what purpose has this sort of calculations, what kind of stress it can take, what kind of thermal load it can take. So these are called thermal load and so on, because it's also one-sided. If it is hot, the other side is cold. then also you have a thermal gradient. So that will change the properties of that particular material also. So thermal stress will be too much. So all these calculations depend on where you are and what kind of, whether it is the outside box you're talking about, whether it is the optics you're talking about, whether optomechanical, the screws and nuts and bolts you're talking about. So if depending on, yeah, so it will depend on the material properties. Yeah. So, yeah. So the Parker Solar Probe has those composite materials. So it was a research for the material scientists to design composites which can withstand that temperature. We still do not have such material in India.
Thank you.
Yeah. Yeah. Yeah.
Larger compared to the surface of sun and even core of the sun.
Yeah. So first of all, so at Aditya, the suit instruments is going to look at the photosphere and chromosphere. So photospheric temperature is about 6,000 Kelvin, chromosphere is tens of thousands of Kelvin. As we go higher, as you rightly pointed out, temperature suddenly goes up to millions of Kelvin. So why the corona is so hot is one of the scientific big problems. Now we have many answers to that. So any normal thermodynamics cannot explain, because you are going away from the source. One thing I should also point out, we do not have any instruments to look at the interior of the sun in Aditya. There are other missions which has detection capabilities of internal properties. You see, you cannot directly see anything inside the sun, but you see certain oscillations on the surface of the sun. Through that oscillation properties, you can infer what is the temperature. You have neutrinos which is generated inside the core of the sun. By studying the properties of the neutrinos, some thermonuclear reaction rates and all that, you can talk about the core of the sun. At Aditya, we do not have such payloads. But you are right, the core temperature is tens of millions of Kelvin. By the time we come to the surface, it is 6,000 Kelvin. So if you go away, you expect the temperature to go down and down. So normal thermodynamics cannot explain it. So now we know that these magnetic fields, they have all these structures, they interact with each other. And there is a process called magnetic reconnection, which converts the magnetic energy into the heat. And that is one viable way of heating the corona. There is also alternative way of by waves. What happens is the surface of the sun is very convective. I did not talk about interior of the sun. It's all convection inside. That's like, all the time there is some movement. So all these movements will generate waves. Any perturbations will have waves. On the top of that, when you have a magnetic environment, so the magnetic field lines are like, this kind of stretched strings. So if you have a string and then you shake the string in the bottom, you generate transverse wave, right? And then the wave will travel along the field lines. So here, because of these radial magnetic fields and the stretched properties of the magnetic field, you can generate a lot of magnetic waves. So there is a wave called L1, which was discovered by L1, who got the Nobel Prize for that. That carries a lot of energy from the lower heights to the upper heights, and then you can dissipate those waves by again some other processes and then heat the corona. So now our understanding is that waves and magnetic reconnection, these two are strong candidates for explaining the coronal heating. Well, it is not able to explain every requirement, so that's why we are still, one can say that the waves will generate, but then we have to identify the waves. You have to detect those waves. So that is what we are doing. So with the Aditya mission also, one of the scientific major thing is to explain the coronal heating. To explain it, you need adequate amount of identification of such waves or identification of magnetic reconnection. And if such a magnetic reconnection happens, then you have to calculate the energy, what is generated by that. And that should be able to compensate the radiative losses and so on. So these are fairly, I would say, understood, but not fully experimentally verified. So theory, physics is always get confirmed when you experimentally demonstrate it and repeat it also experiment. It's not that one of you have an experiment. If you can't repeat it, it is not science, right? It just then it's called hypothesis. So that's the difference between a hypothesis and a law. It becomes a law when you can repeat that experiment and every time prove that that is correct, right?
Sir, during solar eclipse, does the temperature of corona still increases or it remains same?
It remains same because the sun doesn't know the moon comes, so sun behaves the same way. yeah, the hand in the.
Good afternoon, sir. It
Yeah.
was a very informative session. We all liked it, and we had so much to learn from you.
Thank you.
So my question is that you earlier mentioned that if at all a flight has to go from India to US or any other states, any other countries which are much farther. So there is a flight like from Air India. It goes from Bangalore to San Francisco and from Delhi to anywhere. So it doesn't go through the routes like from Europe and all those things. It goes to the from Russia, China, and North Poles
Still
and
higher,
all that.
yeah, yeah.
So you just said that the at the place of poles and all there is a lot of leakage of the solar storms, and because due to this the pregnant women get affected and the womb gets affected on all those things. At that time I had remembered an incident from my village. So a pregnant cow had come out during the solar storm. Sorry, not solar storm, it was a solar eclipse. And at that time, later when the baby was born, when the calf was born, it had some 3 or 4 legs, four hind legs and 2 at the back. It was an abnormal baby. So when I asked my father, it was due to the solar eclipse. So may I know what does the light from solar eclipse does to the fetus when it doesn't even reach the baby?
Yeah. So it is a misconception. Definitely it is not because of the solar eclipse, because if it is anything, actually during the eclipse, if there is a storm, it may not reach us as well, because the moon is actually blocking the sun-earth line at that point of time. So the point is, these are myth, and people had a lot of superstition about eclipses, because in some way eclipses also was considered supernatural, because people didn't know about the trajectories of the moon and the sun and all that. Even we were believing that we are in the center of the universe, right? 400 years back, and Galileo had to suffer for that change of thought. So with eclipse, because suddenly such a darkness used to happen, and then the animal and the birds, they will get confused. In the middle of the day, suddenly it becomes so dark, you can see stars. I mean, I was in the US, I mean, we could see this corona and the streamers too very, very large distance away from the sun. I know what is expected, that's why I was awed and I was so excited. I mean, what magnificent things. But for 200 years back, when people did not have this knowledge, it would be unnatural. So I think the myths and the superstitions grew over the time with the eclipses. I mean, you don't eat during eclipses, that's what it is. I normally, during total solar eclipse, I take lots of laddus and distribute it. So I normally have eclipse, even if there is a partial eclipse and all that, we have live sessions and we showcase and all that, and I eat and distribute mithais. And I say that there is nothing wrong, because sun doesn't know there is a moon on the way, right? So sun is not radiating anything extra. Whatever it is radiating, I mean, at that point of time, if there is a solar storm, it's just a coincidence. But moon doesn't know that sun is there, sun doesn't know moon is there. So what change will happen in the eclipse time at all? So there could be some other, of course, effect which is affected and all that. But what I was telling you, auroras, right? In fact, during this May period, aurora was seen from Ladakh. First time in its history. First time in its recorded history. The flare was so strong, the geo-effectiveness was so strong, it came down to that level, because from India, nobody has seen any auroras in its history. From our observatory, Hanle Observatory, last year there was such an incident. Nobody believed it because we didn't have enough instruments to confirm it. This year it has been observed from Hanle Observatory, IIA's Hanle Observatory. So in that conditions, if you are in space, if you are in air, you are getting exposed to those particles, which is not good. Definitely it is not good. But a cow who is in the, and that too in low latitude, like south of India, you can be safe, no worries. Yeah. Okay. So if you ask questions, you get also a prize. Only for students. Sorry, sir. Good, good. Thank you. Who else had a question? One of the students? Oh, you well. Okay, okay. Sorry, I was looking at. You are not a student, but I'm still a student, okay. Right? There is no end to learning, right? So, thank you. Good, good.
Good afternoon, sir.
Yeah. So
I have a question.
Sure.
Sir, in Aditya, in this 5 different language point is there, sir. How to message passes one-to-one language point, sir?
Yeah.
Is any interaction? Is there IR
no, no. There is no interaction. There is no communication between one Lagrange point to another Lagrange point. These are all imaginary point. These are all imaginary point, right? You make a experiment. You know where the force balances are. So how do you do it? You take a needle or some probe, which will say, this is the neutral point. Sometimes we call stable point, neutral point. So this is a fictitious point. This is not a physical, thing that you reach the top of the mountain and you have reached L1. It's not like that. It's a fictitious point.
Okay. I have another
So
question.
if you have, what I was trying to say is, if you have a satellite here, if you have a satellite there, then we can sort of think about, so this is what is happening. Actually, I didn't mention, it was again Professor Rao's dream, and Professor Dr. Kiran Kumar, who was also former ISRO chairman and now scientist. He has now a dream of making a colony in moon. So we will not go directly to outer space. We'll have a halt place in moon, and then go there. So from here, if you want to travel to US, you go to Delhi, take a little rest, take some more bag and baggages, and go to US. So that's a model people are thinking. So that means moon will directly communicate to that, because directly we are not able to do it. Distance consideration, the solid angle consideration, and all that. So I was just referring that particularly for L3, because there is no line of sight from Earth to L3. So even if you take a satellite at L3, we will not be able to directly communicate. So if you have a satellite here, you can communicate like this. So people are now talking about cluster of satellites. They will talk about it. In fact, I am involved with the Punch mission, which you have seen that. It has a master and it has 3 babies. So a mother satellite and the 3 microsatellites are going to talk to the mother. And we are only going to talk to Earth through that mother satellite. So these are called constellations. So in the constellation, all the microsatellites will not, because they are very, very tiny, small little, you can have a little bigger than a shoebox satellite.
Sir, as you told, suit is covered with 7 filters.
Not covered. What we have is in the optical. Yeah. So what happens is there is a filter wheel. There is a filter wheel. So we take one image through this, and then we rotate the wheel. So another filter is there. We take the image, and then again.
Is
so
any different pore size?
What size?
Pore size. Size.
Size of the the size of the hole. Yeah. So no. Typically the sizes will be all the same, but the material of all the filters may not be the same.
What
so that the
use?
transmission probabilities, we call it pass band of the filters, are not the same. Some will have a narrow pass band, some will have a wider pass band, some will have a very large pass band. Depending on the pass band, you get different instrument, sort of information. I mean, in all electronics, depending on the pass band, you will again a very good question. So I think the other gentleman, he asked this, that we are planning to observe different layers of the atmosphere of the sun. So different filters are actually having properties of passing certain wavelengths which represent certain temperature emission from different layers of the atmospheres. So when we say magnesium, 2 filter, that is probing a say 2000 kilometer thickness from the height of the atmosphere. When we say calcium, it is about 1500 kilometers height. So it is probing different. As you know, when we look at red, green, different layers, we are actually looking at different temperature, right? So likewise, if you look at different near UV pass bands, you are actually able to see different thermal plasmas, and that corresponds to different layers of the atmosphere of the sun.
Thank you, sir.
Yeah, you have a book. The lady first. Please, Nari Shakti. I mean, abhi Nari Shakti ka time hai. Please, sorry. I mean, just I will entertain you also. You can use the microphone for other. Yeah.
Good afternoon, sir. As we are launching too many satellites, is there a mission to clear out the dead satellites?
Yeah. So people are all talking about it. As I was indicating, this debris is a very, very big problem now. So yeah, these processes are already ongoing, that whether we could launch certain things to deviate them. So the satellites and all that, the impact assessment was not there. There was an event in 1876. This is called a Carrington flare. Now we know that during the Carrington flare, there was huge geomagnetic storm, and in fact, there was some ground stations which were used Earth magnetic field. Earth magnetic field got changed during that impact, and that is there in a historical record. If such a Carrington flare happens, we still don't know how much damage will be there in Earth. So we try to actually really assess, as you said, this assessment is very, very important. And in fact, since we were all talking about sun, there are other stars, which is sun-like stars. So there are missions which are dedicatedly looking at stellar flares, and there are certain strong flares which is observed for stellar. Then there are nature paper from Japanese group. They have predicted that if such an event happens in the sun, some portion of our civilization can get damaged. Okay. What is the probability of such thing happening and all that? There is also some research going on that. So this impact analysis depends on how strong this, and then whether the sun is going to be much more magnetically active in near future and all that. We all do that actually. It's my. Yeah, so for that kind of study, you need very long-term data. Not 5 years or 10 years data is not enough. You have to know thousands of years of data. So since you asked the question, I have been responsible for Kodaikanal observatory digitization program. So we have been looking at the sun from Kodaikanal, again IA's observatory, for more than 100 years. So I've been looking at this 120 years of data from 1900. And we have lots of new information published. I have 5 PhD students who have just worked on that data. But now we have to go back to millennia. But solar observation is not there because telescope was not discovered 400 years back. I mean, it was just 1405 when it was discovered. So 1605. So that means you have to go back with other proxies. So there are other carbogenic proxies. There are ice core results which produces this. There is also thing why the dinosaurs were all gone, whether there was a huge solar storm responsible for that. There are all these possibilities do exist. Okay.
So thank you very much. Come, please come. Those who ask questions, please.
Good job. All the best. Oh yeah. Which college you are in?
Garden City University.
What university? Garden City University. Wow, Garden City University. I didn't know. As I said, you know, you're still a student. We are all students. Okay, thank you. Okay. Okay. Oh, okay. 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 Thank you.
I would like to thank Dr. Deepankar sir for a wonderful presentation. I'm sure we would not have had a better presentation than this on the occasion of National Space Day. We are very grateful to you, sir, for your highly inspiring and scintillating and scholarly talk. And on behalf of KSTA, we would be honored to present you a small presentation.
Okay, okay. Thank you very much. Thank you. Thank you very much. Thank you.
I take this opportunity to thank Dr. Giri, Dr. Srimati Giri, Dr. Shri Basuraj, Shri Brungesh, and faculty from IC Bio, and all the students from different engineering colleges and science colleges like Soundarya, IC Bio, Reva, Garden City, BMS Women's College, and Shri Krishna Institute of Technology. For all of you, a big thanks. I am also thankful to Shri Vishnupant Kulkarni, who has joined online. Along with him, more than 100 students from Goa have joined. For all of you, thank you very much. At this juncture, I request Deepankar sir to organize a workshop at KSTA and Aditya Mission so that more interested students, especially PG students, will be benefited by your workshops. We have accommodation also.
Okay.
Yeah. Yes, sir. So, thank you very much. We have lunch. Please join us for lunch.
So before lunch, so please we can have a group photo with Banerjee sir.
Yeah.
It's our proud privilege to have a photo with you, sir. So thank you, Unandal, and thank you very much, sir, for your very interesting lecture. Yeah, we can have a group photo outside, sir. Please, sir.